Good morning, good afternoon. Welcome from wherever you are in the world today. I'm Guy, the product marketing manager for Geomagic at Octon, and today we're joined by James Jenkins, 3D application specialist from Rapid 3D, based in Western Canada. He's going to be showcasing a scan-based design workflow focused around retrofitting the inside of the van. A few housekeeping bits before we get started. You should see the GoToWebinar control panel on your screen somewhere. Throughout the webinar, if you have any questions, feel free to drop them in the questions drop down. It's about halfway down. If there's any other comments or you want to have a chat between you, there's a chat box in there as well. The presentation will run for probably 45 minutes or so, to leave around 15 minutes for questions at the end. We're also joined by Sean Parker, one of our applications engineers based in the US. He may jump on at the end to answer any questions that he is best suited to. So if you hear another voice that's not mine or not James's, that's what you'll be hearing. So without further ado, I'll pass over to you, James. Thank you for joining us.
No worries. Thank you. So a little bit of background here on Rapid 3D. So we started back in 2009. I've been with the company since about 2019. So we really specialize in tackling unique measurement challenges for all of our clients, utilizing scan data in sort of new and innovative ways. We cover every industry from arts and culture to anything that starts with Z. So really, if it's out there, we've probably seen it, we've probably scanned it, and we've probably measured it in some way or another. I've been working with the reverse engineering and design team since I came on board. Design X, what we're going to focus on here today, is really my bread and butter. I'm in the software nearly every day, utilizing scan data, again, from multiple different scanners, different types, and in different sizes and ranges from every industry imaginable. So today we're going to focus on scan-based design. So the typical workflow for something like Design X would be more focused on reverse engineering. But really what we're talking about today is how can we create complex designs that don't need to reverse engineer an entire part. You wouldn't model your entire house or build an entire house just to change a light fixture. You would essentially measure and locate all your wiring and where you want to put it, and you want to see how it looks. So really what we're doing today is making complex models, things that need to work with other features and existing parts without actually backtracking and reverse engineering our entire van today. So I will be using Geomagic Design X, multiple tools within there to go through that workflow. We're really aiming for first time fit in this kind of thing. So Design X is going to allow us to use workflows that eliminate some of the guess and check nature of design. So there's no more going back and forth measuring, things like that here. So we're looking at a Sprinter van here. The van life has become quite a phenomenon worldwide here. So we just decided to do something a little bit fun with this. Probably not something we would normally tackle, but it was something in my wheelhouse that I wanted to look at here. So the intent was to design something that is going to work with our van without requiring us to model the entire van. If we have Design X or if we have Geomagic for SolidWorks, if we have a way that we can create these mesh-based measurements, we don't need the entire CAD model of the van, the original, anything like that, in order to create these interactions with all the parts that we're going to be using here. We also aren't required to, prototype or make physical models, whether it's out of, steel or out of cardboard, just to make sure that something's going to fit. As I said before, this really eliminates the need of running back and forth to a vehicle, to our van, to a warehouse, to any sort of feature that you're trying to measure and trying to do this work on. and then take measurements and then run back to do your design and then back and forth. You don't longer need to have that sort of inventory of the object physically in your presence. Once you've captured that real world scan data, you can use that to leverage the workflows that we're going to show some of here in order to create that model. It also allows the designer to see potential issues and develop solutions that interact with your object and visualize the space in a different way. You don't have to, create a model and decide that, yeah, I like the look of that. But then once you install it into your van or, add your feature to your factory or anything that you're working on and realize that this doesn't really fit or it doesn't do the job I want it to, we can see here in real time as we model sort of that interaction with the real world. Some of the cross-sectioning tools and extraction tools that we have in here allow us to measure very complex geometry that you would not be able to do with a tape measure or machinist square or many other types of measurement tools out there. And 3D scanning really gives us that flexibility. And of course, Design X with the tools available give us ability to measure very complex geometry that would not otherwise be possible. So when we're talking about scan-based design, what we're really talking about here is using scan data in a way that is different from reverse engineering. Rather than model the entire frame of a vehicle just to fit a bracket, we just need to know the area that it's going to fit, that it's going to work with the objects that are in the specific area that we're interested in, as well as clearances, bolt locations, all those type of things. This can be used in any area. So if you're modeling to, like I say, a factory, or maybe you need to do new piping runs in your plant, all of these type of objects can be scanned, and you can work with that scan data in a way to utilize space more effectively, reduce the need for, like I said, that back and forth measurement. Really, it's going to give you the fastest way to get from your scan data to CAD models that function in your environment. Design X here is a fully functional CAD suite, as well as all of the benefits of the scan to CAD extraction tools on top of that. So you could do clean sheet design all the way through, as well as leverage that scan data. So the tools that we're using today are based in Geomagic Design X. Now, why would we choose Design X over something like Geomagic for SolidWorks? In our case today, we're dealing with a very large amount of scan data. So large data sets, we can use batch processing to process that scan data in different ways, do advanced alignments. Again, complex scan to CAD projects here are really what we're focusing on. We're also using more advanced surfacing tools and modeling tools. Geomagic for SolidWorks, on the other hand, has a much lower barrier to entry. It works directly inside SolidWorks as a plugin, and you can do a large majority of what I'm doing today right inside SolidWorks with this tool. It's much more intermediate. If you're already familiar with SolidWorks, you will jump right in, whereas Design X, there is a bit more of a learning curve to it, but it's going to function like most other CAD software with, again, that added benefit of scan to CAD utilities. So let's dive in here. So this is our Sprinter van that we're looking at here. So I'm working on a relatively powerful CAD computer, but nothing top of the line by any means. I do have my mesh split up into multiple areas here. So I'm just using our interior because that's what we're going to focus on today. And I'm using my smart selection tools to just extract some planes. I have some very flat features on the side of this van that I want to use to create this mirrored sort of entity. So I'm grabbing a plane on each side, and then I'm going to send one straight down the middle. Now, this alignment that we're about to do is probably the most critical step in any sort of scan to CAD project. If you're trying to work with scan data that is not aligned properly, you're going to end up having to go back and forth and do a little bit of work making some adjustments and modifying things side to side here. In this case, we're going to do this alignment based on our rear axle, as well as the plane of the floor. So the alignment tools that Design X has here are, I would say, far superior to most others. I'm just extracting the sort of tube of the rear axle. You can see there's a little bit of offset, probably parked on a bit of a dip in the floor. But I'm also going to leverage the ability of the extraction tools here to give me sort of the plane of the floor, the axle center location, and that center down the middle of the van here to give me a very rock solid alignment. We don't have to rely on sort of eyeball moving a mesh into place, or dialing in measurements one click at a time, or typing in measurements and remeasuring and checking. We're able to extract this very accurately and essentially give us all that we need to create a very solid XYZ alignment here, again, without that manual interaction. I'm just doing a little quick crosshair here to give me a location for my origin and an axis. I'll go ahead and bring in my mesh again, pull up my interactive alignment tools. I can actually move all of my meshes at once. So this scan data set, each scan is aligned to each other, but they're not aligned to the global origin in any way. But I can actually choose to move all of my scans at once. So they maintain their individual alignments to each other, but now I'm going to move them all globally into position. So you can see here, I'm given the options to choose which direction everything is going to face. I have full control over where it is, and then it's basically pulled from that extraction data that I've grabbed. Now that my alignment's complete here, I can go ahead and nuke out my sort of alignment features. And you can see that we're now aligned in sort of a more classic front top side view. So here's our isometric, and you can see all of our additional scan data. I've just rolled forward here, so I have the full model complete, and I'm going to roll forward for you guys. So you won't see absolutely everything, but I am going to touch on it all as we go. Our scan data here is split into multiple sections. This gives me the ability to work with just the interior or just the exterior, as well as doors in open and closed positions. Oftentimes, especially with vehicles, we have a lot of moving parts that need to be able to have clearance, to move independently of our model. Everything still has to function in our van. We can't just weld a door shut because we put something in the way. So we want to make sure with this we can sort of pull all this up and have individual scans as we need. Now, as far as Design X and handling this data goes, we're dealing with almost 60 million triangles of scan data when all combined. And you can see it's sort of operating quite smooth here, depending on your video lag on the other end. But I'm navigating around here with very few issues. My first task is going to be to set up a floor. So I'm going to offset this floor just off the surface. I want to leave room for some insulation. And our cross-section tool, you can see here, cuts perfectly through the mesh right on our plane. And this sort of teal line that's going to be created is our cross-section. The sketch tools allow me to create and snap to those polylines that are created by the cross-section. I can check for clearance. I can fully dimension. I can complete alignments in those ways. You can see I've added a little extra clearance on things like the wheel wells. After all, we will need to shove this piece of plywood or whatever we're going to make this out of through the back door here. So once I've got my sort of floor plane in, I need a support system underneath. So I can't just have this floating on some styrofoam insulation. You can see it's snugged right up into the wheel wells and everything all the way around. Now I'm going to utilize my scan data in a bit different way. So rather than a cross section, I'm going to visually place some cross members for this floor support to basically land right on the frame rails of the vehicle. So you see here when I zoom in, I'm placing them on the high points and down the frame rails on each side. So we have the maximum support for our floor system. but also giving us this large area for mounting things like cabinets to a very solid base, as well as giving us this offset. So once I complete my extrude here, you can see I can bump this up into solid bodies and create that frame. If I wanted to, say, bring this into SolidWorks or do a live transfer to SolidWorks, I could create cut lists for this for weldments. I can also create a 2D CNC path for my floor if I wanted from just a DXF of that sketch. So now that I've got a little bit of support under my floor, I'm going to start working on something that I've always wanted to do, which is a rear fold-out deck. Now, a lot of enthusiasts of the van life here, a lot of their life is spent outdoors, and I wanted to extend some of that sort of internal space outside. So I wanted to create a folding deck here that pivots down from the back of the vehicle without necessarily just hanging off the back with while you're driving down the highway here. So what I'm doing is at the moment just offsetting a plane here off my base floor. So that's going to be my sort of my mounting structure. And I'm just creating some very simple swing arms. So each side's going to have a swing arm. I'm just copying that sketch essentially from each side and mirroring that swing arm over. So obviously it's going to interfere with my floor at this point. So I need to do a few quick tweaks and make my cutouts. And once I've got that, I can start establishing how I want to attach this to the van itself. Now, it needs to be securely mounted to the frame of the vehicle. You could potentially have a few people standing on this, a fair amount of weight happening and leverage. So we want a secure mounting. So using my mesh sketch tool again, I'm taking this cross section at the rear of the van, just a small portion this time. I'm going to create a spacer. So the spacer is going to bump my mounting location up from the floor to get it level with where I need my pivot to be. But you can see I can very cleanly match the profile of the back of the van here without having to manually go out and trace it on cardboard or take measurements with radius tools or anything like that. So I'm just clipping my scan data view back so I can have a look right through my solid, and I can see I'm just perfectly on the surface of my mesh here. So that just tells me it's going to sit right on top of my van's floor. And again, a urethane or anti-vibration spacer is what we're after. Right now, just bringing in sort of a steel bracket. So very simple bracket building here, just multi-piece welded assembly. Just grabbing some supports, extra features, and make sure I put my hole through for my pivot. But now I need to be able to clearance this. So I'm just going to add a clearance for a nut or a clevis pin to go on the other side of this assembly. And again, as I'm doing this, I'm mirroring across to both sides. Again, we've aligned this so we can confidently mirror things across. One of the biggest challenges with a vehicle or even, say, buildings going through walls or vehicles going through floors is ensuring that I'm not going to puncture a brake line, a gas tank, a spare tire. Utilizing my scan data, I can position it where I think it needs to go, completely flip it over, again, depending on how complete your scan data is, and I can see exactly on each side where I can place this bracket. I can obviously see there that there's no features in the way. There's no brake lines, no electrical, nothing that I need to worry about. So I'm free to punch those bolts right down through my object and create that path for the mount. I can also go ahead and create a support bracket off the side here. Spaced it off with my spacer. And from the side here, I can see there's some anti-corrosion sort of undercoating here. That will need to be scraped away in order for me to mount that bracket. But I can tell it's not going to interfere with my CAD model. So once the bracket's in place, if I needed to clean that off, whether it gets welded or bolted into place, I know I have the room to do that. And I know I'm right up against the frame of the vehicle, or in this case, the external body line. So each side I can just double check. Again, no vehicle is manufactured the same. In our case here, the Sprinter van is one of millions. So everyone has slight deviations and differences, but because I have the scan data of my particular van here, I can design exactly to that van, or I can design with some clearances and the fact in my head that if I want to mass produce this across multiple models, multiple vans, if I have the scan data for those vans, I can confidently design things that will fit to any van, as long as I have some considerations in place here. So I've just extended this little rear deck here, and I'm going to pivot it up. Basically, I want to check, is it going to clear my door? Is it going to clear my floor pivots? How does the curvature of the rear of the van factor in? So I've just rotated my van up, or sorry, my van. I rotated my rear deck up on the actual pivot that I'm going to use. I can check here. I actually found that about 91 degrees gave me the exact clearance I need. I can turn my scan on of my door. So not only can I check and make sure that it fits the body, but I have the door in its closed position. And I can pan up here and I can check that, yes, I have ample clearance forward and back. That's just fine. And then when I flip around, I can check if I have clearance from the side on each side of the vehicle. What I am seeing here is the wasted space. So I talked before about utilizing extra space. So with our silhouette mesh sketch here, I can essentially do that hand puppet flashlight technique here, and I'm going to project the entire curvature of the rear of that door rather than in a single plane, but in this sort of box method. I can get all of that curvature at once. Now, once I have that, I can create that design to utilize all the space I can with as simple manufacturing as I can, rather than going with curved metal and bent features. I'm just using, square tubing here. But you can see just how close up I can get to the sides of my vehicle without interfering with it in any way. If I was to try and measure that with a tape measure, it has a taper upwards, it has curved edges, it actually tilts forward toward the front of the vehicle as well. So a very complex opening is able to be modeled in a way here that we have very little concern about it ever having an issue with clearance. Again, that guess and check methodology that we normally would have to employ here, I would have to create a design, possibly create a prototype or a model, a physical model somehow, and ensure that it swings open and closed. In this case, because I have the scan data live with live feedback of exactly where this is going to fit, I have no concerns about this vehicle being able to open its rear doors and swing that sort of deck down. Now we need to create a bit of a shell here. So we need to panel our walls. So I'm going to grab, again, a silhouette here of our upper ribs, our vehicle ribs, and it's going to allow me to get the curvature. Now, if you've ever cut a flat piece of plywood and tried to fit it to a curve, you know that it shrinks on the sides. So this will allow us to make sure that when I put my curved piece in, I have the exact length of that arc that needs to be cut in order to bring that in. And again, whether we bring that into something like a CNC router or water jet or any of the above, we're confident that we have the material that we need. So similar with the walls, I'm just going to trim all this together here, and I'm going to give myself essentially this envelope to work in. So this upper portion, lower portion, I can check for clearances. We have these odd little bumps in the walls. I believe they might be seat belt anchors. But we can make sure that we have clearance around all of those, because otherwise it would push this sort of feature outwards on the vehicle, and we wouldn't be able to properly fasten it to the walls. All of these features also have room for insulation behind them that I'm considering. It's going to be those empty pockets. So this rear section is a bit more complicated, again, because we have this curvature happening. We have some angular features. I really wanted to mimic the rear opening of the van as best as possible. So I don't just have this, big square wooden opening. I wanted to be able to cut that smoothly. So if we're looking from the inside of the van here, we can see that the whole curvature just matches perfectly with the sort of plastic shroud that's on the existing van. I don't want to fully remove that shroud because there is a lot of electrical and everything in place here. And I just wanted to, cover that in Make sure it's still accessible, but it's not visually obtrusive. This upper wiring channel up top there, we're going to relocate and actually hide in behind some cabinets. So I'm going to go ahead and bring in a few of the cabinets right away. I won't bore you with the extrude and sketch nature of some simple box cabinets. So we're just going to whiz through these real quick here. Essentially, all I'm using is the existing surface to cut and trim my solids, just like any other CAD software. The real benefit is I can see how these cabinets are going to fit and interact with my entire van right from the inside. I don't have to make one, place it in, and go, you know what, this thing is too big. A lot of the vans right now that are in this sort of van life trend, their beds are all going across the rear of the vehicle. I'm a tall guy. I wanted a long bed, so I was able to position one sort of central here. So our upper cabinets give us a bit of a challenge because we need a solid surface to mount them to. So you can see I've taken multiple cross sections across the ribs of the vehicle as well as that sort of side support brace. What this allows me to do is mock up my cabinet in a sketch, but really lock in these two square sort of mounting areas here. So these mounts are, whether they're a U-channel style rail or just a wooden purlin tile stipe mount, we have an exact location for where those need to be, that they're not going to interfere with anything. And then we can just extrude them right in here and trim them to fit. So I've just run them long in case I want to run my cabinets. I'm going to trim them off. And then I'm going to start modeling that cabinet in here. So we're going to hide that electrical, tuck it right in behind our cabinet. You can see it's got a little bit of clearance on the rear. And again, standard CAD tools here, just using booleans and subtractions and cuts and transforms, and I can just pattern my entire cabinet rather than redesign each one. Send them straight across. Get rid of a couple doors to give us a little bit more of an open feel here. And now you can really see how our van is kind of stacking up and coming together. We have a nice kitchen area in the rear with this lower down deck. We've got the bed. We've got everything that we can kind of get in, but now we need to get some mechanical features going on here. So we do need a vent. If anybody that's done the van life knows, things get humid in there, especially if you're cooking, you're in there, you're living. What I'm going to use here is what's called a mesh fit. So a unique Design X feature here allows me to essentially shrink wrap a surface down using this region I've selected and create as exact a duplicate as we can in CAD of some curvature features. This is going to allow me to create a vent opening. So whether you're an industrial designer, manufacturer, or a hobbyist, and you want to create a unique part that fits this specific vehicle, the mesh fit is really a great way to do this. So this, like I said, gives us our shrink wrap feature here, gives me a very, very tight seal to the surface curvature of this. I can use that just as a regular surface like any other CAD feature. I can offset it like I've done here. I can use it to cut solids. I can use it to trim to other features. And just going to go through and make a very simple vent opening that's going to slide down in through a hole cut in the roof. Once that's in, I also have room in between our curvature. So the lower portion of this vent is actually going to match down here the curvature of the roof that we have in place. Again, I'm a tall guy. I don't want you lose any space vertically. So I'm trying to make this whole roof area as tight as possible. So you can see there's our gap for our insulation there. And we match the curvature both inside right here, as well as our sort of seam like along the top. We could seal that now with silicone or a foam tape, rather than relying on something like an expanding foam that's likely going to leak over the years, or even just globbing on the make a gasket to make that seal. One of the more unique features I wanted to bring in here was a pair of water tanks in the rear of the vehicle, but I don't want to lose my spare tire. Emergencies happen. I want to have that spare. One thing I do need to do is relocate our exhaust. So it runs right in an area that I want to bring up. So I'm using, again, my sort of unique Design X selection tools for my mesh, using my smart selection tools to grab as much of this exhaust scan data as possible. And we're going to use a tool called Pipe Wizard here, unique Design X feature that allows me to create a surface model or even a solid model of this entire exhaust pipe without having to actually do any sketching, any planes, any of the complex bends or sweeps that would normally be used here. So quick few settings to tell it what kind of data it's looking at here. It's going to run a quick calculation and create a 3D sketch sweep path and my circular sweeping sort of exhaust pipe here. So you can see once we've completed our tool, we can make adjustments, all that here. But once we've got this in, this exhaust pipe is going to fit exactly. And this isn't even a complete full circle scan. We only have about 3/4 of the exhaust here because we weren't able to scan up above it. Now the rear portion here is what I want to trim off. So again, this is a CAD surface feature. I can interact with it just as I would with a sketched or created solid or surface. So I'm going to chop the end of our exhaust off here. And we're going to remove this rear section. I want to put a pair of twin water tanks just at the rear of the vehicle. So go ahead and clip that off with a plane here. And I am going to do a quick sketch on this new plane. And I want this exhaust to exit just after the rear wheel. Now, I did actually look at creating some dragster style exhausts, but I figured that might be a little too high profile. So I'm going to do just a very simple turn down here. So once I have a sweep path and a sketch created for this, I can go ahead and make another CAD surface. So you can see I'm utilizing that mesh sketch to tell me exactly where I need to place this exhaust. So mesh sketch through the undercarriage portion here, and I want to just come below. So I'm giving myself that offset distance of the size of my pipe, and I want to create that sweep. And then I want to join these together. So I'm just going to do, again, simple CAD loft. Going to loft these together. There we go. Can trim off the end to a sort of an angular tip. And when I turn my scan data back on, you can see just how well that looks. It's a factory style exhaust, just sort of exits right after the rear tire. We're not too worried about any sort of exhaust coming into the cabin. We didn't modify any of the rest of the exhaust, but now we know exactly what that bend needs to be. We could have this entire exhaust system sent off and manufactured from a model now. So now that I have my exhaust modeled, I no longer need this small chunk of scan data here. So I'm going to go ahead and remove my exhaust. Since I've taken care of that, I'm not too worried about colliding with it anymore. So once this comes out, I have this free space now in the rear to create my water tanks. So you see our exhaust just exits right out the side. Our mesh data comes right up to where that bend is. And we're free to design and work around our mesh without that in the way. Now for our water tanks, I didn't want to lose any ground clearance, but I wanted absolutely as much storage as possible. I believe each one here is about 50 liters. So a pretty sizable amount of water. So whether you used one as a water and one as a gray water tank, anything you needed to do here. But again, utilizing these extraction tools, this time I'm not, snapping to my features, but I am making sure I have about a good 1/4 inch of clearance all the way around this tank. I'm also making sure that I'm clearing bolts, I'm clearing features, and I'm using the side profile of the van here. So this profile is a sort of a unique sort of sprinter look, sort of tapers up at the end. And I wanted to mimic that, but dropping it down to the same level as my spare tire here. So when I do that and use this feature to trim off the bottom of my water tank, once I get it put into place here, we're going to clean this up and do a quick little fillet and things around the end. So this would be like a roto-molded style plastic tank. When we look from the side of the vehicle, you can really see that it blends in with the vehicle, looks as factory as possible. It doesn't stick out. We're going to add these two in, like I said here. We're also just right at the same level of the spare tire. So we're not losing any ground clearance. We're not hanging low, but we're mimicking the style of the vehicle and utilizing as much of that space as we absolutely can. So lastly here, I want to create kind of a level feature. So I want to be able to add some drop down legs to the rear of my van, but I want to make sure that the van is actually leveled first. So most vehicles have a little bit of a rake front to back. So I'm just going to put in some cheesy little ramps here. This was more for fun than anything, but gives you an idea of just kind of where we're sitting in relation to the ground. But really the key here is I want to make some drop down legs that will pin into position. So I want this rear deck to be nice and stable. So once I get sort of these features in, I can add this sort of telescoping style feature, probably just a very simple pin type connection. And I can make sure that the extension of that drops right down to my ground level, and then some in case I'm parked on a hill or some uneven ground or anything like that. But I want to make sure that that extension isn't going to interfere with anything when I fold it up as well. Um, I don't want to add these legs and then all of a sudden have my doors not be able to close. So I've got my doors open here, just in their first open position. Everything clears my rear patio or deck area. Um, we could create an awning or something that spans the top to create a little bit more of an enclosed room, maybe make a shower in the back if you wanted to. Really, the features are endless here. Then we're just going to go ahead and, again, pivot this guy up and pivot the legs down. So in their stowed position here, just adding a bit of rear sheet decking. And once we stow this, I want to verify that these legs are going to fit into the window pockets in the back doors like I intended. There we go. And then just going to drop these legs down into their stowed position. There we are. So once again, I can turn on my scan data. I can get a feel for the space. I can get a feel for the clearance available. If I need to, I can measure the clearances. I can check for things like interference. I can pivot this entire rear section up and down. But really right now, like I said, I want to check the clearance to the rear windows here. And you see they just tuck nicely into these pockets. I've got lots of room to add maybe some cushions, trash bags, anything that wants to be sort of be sandwiched back there. And really, if I turn all my scan data back on, we've got a fairly complete concept model at this stage. Obviously, there's a million more things we could do here. But as far as a sort of proof of concept, we've got something in. I did a few quick renders here just to give an idea. So these are just the models pulled directly into a rendering software straight out of Design X. So you can see I've got the two laid side by side. And again, having that scan data available without having to model this entire vehicle allowed me to create a very workable interior. It has all the features that I personally want. As well as being able to make sure that everything is going to fit the first time. I have no doubts that I could go to manufacturing with any of these components and that they will fit in the vehicle where they're intended to fit. All right. It's a lot of me talking, but I think pass it off back to Guy here and get some questions rolling.
Thank you, James. That was super interesting. We have a few questions here. The first one around SolidWorks. Obviously, you mentioned Geomagic for SolidWorks at the beginning of the presentation. Can you import the scan data directly in SolidWorks for a similar workflow?
Yeah, so when we're talking about Geomagic for SolidWorks, absolutely. Your scan data is going to import in a very similar manner. Alignments are going to be completed in a similar manner, same as your extractions and sketches. Now, without the plugin, SolidWorks does have some basic mesh capabilities, but it is nowhere near the function. We're not getting cross sections. We're not able to extract features and planes from our mesh. and even alignment can be a bit of a bear. Geomagic for SolidWorks really opens up the mesh capabilities of SolidWorks to really a whole new level. Like I said, a lot of the workflow that I've done here are very simple CAD operations. Um, but Geomagic for SolidWorks allows SolidWorks to do those operations while leveraging just that infinite measurement capability of the scan data.
Great, thank you. We have one here. What scanning hardware was used for this, and was it processed in Design X?
Gotcha. So the scanning hardware for this was done with a Creaform Metroscan Black Elite. The first initial processing was completed in the scan software, so the Creaform VX Element software. Once our scan data was cleaned up and finalized, we exported, and all of the trimming and sort of moving meshes around and splitting things up was actually done directly in Design X.
Great, thank you. We've got one. What was the rendering software you used at the end?
I believe we've used a few different ones in the past. I did bring some into SolidWorks Visualize and just ran through some of their very simple tools, assigned textures to meshes and things like that. Again, a powerful visualization tool. The key there, though, is being able to have the model and the mesh interact together and give you a real idea of what the space is going to look and function like.
Great. We've got one here around alignment. So uh, it looks like you had seven different meshes in that Design X instance. Did you scan them individually and then align them all? What was the process for that?
Yeah. So typically with vehicles, something of that size, it's going to be more than one scan session. I mean, most of our scanners can operate on anything, from the size of a dime all the way up to entire vehicles or entire facilities if we go that route. This particular one was scanned in multiple sections. So the interior was probably scanned in 3 to 5 sections. The doors sections were all scanned individually. And then everything was aligned mesh to mesh alignments within our scan software and then brought into DesignX as it sat. So you saw when I brought all those meshes in, they were aligned to each other, but not globally. So DesignX allowed me to take all of those meshes all at once and move them into a position that is workable for my CAD model.
Great. We've got one here asking around other new components. So if you're going to make body panels or fenders or anything like that for the van, what kind of process would you follow to create those in Design X?
Yeah. So there's definitely a couple of ways to go about that. If you're looking for an exact replica of your specific vehicle, DesignX has plenty of auto surface and mesh fit type tools. So similar to how I did the roof vent, the mesh fit allows us to sort of shrink wrap that CAD surface direct to it. Now, the only thing that these don't have is a parametric quality. So we can't go in and edit a curve or make a change necessarily directly to that mesh fit. So the other option would be to go about and use our cross sections at multiple locations to create lofts, to create revolves and extrudes of surfaces or solids at different points in order to create the curvature of the body panels that are existing there. And we have plenty of sort of direct comparison tools in DesignX as well to be able to look at our modeled version and then compare that directly to our scan data and give us deviation maps, heat maps, color maps to tell us, I have a wrinkle here, I have a bump or a dent here. This I need to ignore, this I need to model. There's a lot of surfacing possibilities available and something that we have done quite extensively in the past in DesignX as well.
Great, thank you. Um, we've got one here. I know you mentioned earlier in the presentation about working with other industries. Obviously, this kind of workflow is super powerful for like aftermarket automotive, and as you showed the van design. But is there any other industries that this kind of workflow would be suited to?
Yeah, I did mention a few earlier as well. Something that we have seen coming up a lot is retrofitting facilities for new operations or new processes. Whether it's pipeline transferring or wiring that needs to go into a building, large equipment that needs to enter a building. We've even done projects where a very large piece of equipment needs to come into a very small space, and what operations are needed to get that equipment in. Really, you can leverage the scan data in any way you can possibly imagine in Design X to measure, to create, to design, and to engineer nearly anything. Um, you want to make a custom bracketry or a custom door opener or any type of thing you can absolutely think of. It fits so many industries. It's unimaginable. We use it nearly every day.
And one final one, unless anyone else has any last minute questions they want to add to the chat. This one may be one for Sean. You did mention about your system requirements, your laptop specs at the beginning of the presentation, but is there like a general rule, a system spec for a laptop to be able to run this?
Sean, did you want to grab that one then?
Yeah, I can take that. And generally my rule of thumb is that the scanner is going to generally have more stringent system requirements than the software is. So if you're going to be, running something like a Creaform scanner, they are going to have Quadro RTX A5000 kind of series graphics cards, very high-end cards, in order to run that scanner. And if you can run the scanner on the software, run the scanner on the computer, the Design X software will run just fine. The system specs that we have them listed on our support site. They are minimum specs. So it's something like, 1 gigabyte of graphics card memory, which is very, very low. I think it wants 2 gigabytes or 4 gigabytes of RAM, things like that. So very, very low end. You can run the software on a pretty under-spec'd PC. But it certainly is going to bog down, especially on larger data sets like the ones that we've been looking at today of these vans. Really, the performance of the software is directly related to how well built that computer is to handle large point clouds. So, definitely looking at higher clock speed as much as possible for single thread operations for point cloud mesh processing, but balance that with a healthy mix of, a large number of cores or threads available in your processor for the operations in Design X that do support multi-threading. And then, of course, a solid state drive, we can not recommend that enough because the read-write times for a solid state are much, much faster than a spinny drive. So if you do want to know a little bit more about that, we can certainly get those specs to you. But generally, like I said, if you're buying the software along with the scanner, which the vast majority of Design X customers are doing, that scanner spec is going to typically be more stringent than ours. So just buy the computer that fits with that scanner, and it should work just fine with the software too.
Cheers, Sean. Yeah, if you head to the Design X page on our website, we have links to the full system requirements. So if you want more of the specifics, then feel free to head there. And if you've got any questions, then reach out to us that way. I think that is all the questions answered. James, thank you very much for joining us. It was super interesting. I'll pass back over. You've got a final few remarks.
Yeah, just thank you for everybody for coming about. During the COVID times here, when things were fairly shut down, we did get into scanning these vehicles just as sort of some make work, and it's really turned into quite a fun project and a very useful one for many people. So we do have quite a few vehicle scans available for sale. The scan data, as well as some of them, have been reverse engineered as far as internal modeling goes. So do check us out. We have all of the usual socials here. So have a look on all that. Get in touch with us. We do offer scanning services, whether it's scanning, reverse engineering, modeling, drawings. We also offer a number of different products as far as Design X itself, and then software in relation to scanning, Control X, and a few others for utilizing all that scan data. We do also, retail several different scanner models if you're interested in getting into the scanning and designing workflow. So check us out, and thank you again for stopping in, and hopefully you enjoyed what you saw.
Great. Thank you very much, James. Thanks everyone for joining. Have a good rest of your day, and we'll see you on the next one.
Thank you.